Hey there, my name's Gary Sims and this is Gary Explains. Today I want to look at a thing called ZRAM, that's compressed RAM that can be used for swapping, and why and how you can use it on a Raspberry Pi. So if you want to find out more, please let me explain. Every computer has RAM, random access memory. It's the main memory where apps and their data are stored. Every time you start a new app on your Raspberry Pi, the web browser, text editor, or calculator, it consumes some of that main memory. Now at some point the main memory is going to run out. Raspberry Pis start at half a gigabyte and go all up to 8 gigabytes. There's a big range of different memory configurations. At some point you're going to run out of memory because it's a finite resource. Now obviously that's harder at the higher end, 4 gigabytes, 8 gigabytes, but the lower end, half a gigabyte, 1 gigabyte, that is actually a real possibility. Now what does the computer do when it runs out of memory? It could just throw up its hands and go, that's it, I can't do any more, I've run out of memory. Or it could try to do something about it. Now there is a technique called swapping, which was invented many decades ago, which handles out of memory situations. The idea is this: when the computer doesn't have any more memory, when your Raspberry Pi doesn't have any more memory, it says, well, is there any memory that I haven't used for a while? Something that's kind of just sitting there occupying space, but I'm not actually using it. It finds a block of memory, a page of memory, and then writes that out to some storage. In the case of the Raspberry Pi, that would traditionally be the SD card. Then that place of memory can then be freed. It's now got a gap in the memory, and the new memory that you need for the calculator app or whatever it is you've started can go into that page. Now obviously this happens many times over the whole memory range, and that allows the computer to keep functioning while it has ran out of physical memory, as long as there is swap space, a storage space, that memory can be written to. Also the opposite happens. If at some point that memory that it wrote out is needed, it will go back into the disk, it will find it, and it will put it back into another page of memory. Now to do that, the other page of memory itself might also be written out to the disk. Now if too much of this reading and writing is going on, that's called thrashing, which means the computer slows down an awful lot because it's spending most of its time trying to find spare bits of memory and can never actually really succeed. Now the problem with swapping is that you're writing out to the storage, maybe an SD card, maybe USB drive, okay, and that can be slow, certainly is slow compared to obviously how much you're accessing physical memory. So you want to be able to speed this process up as much as you can on a Raspberry Pi, and the way you do that is using something called ZRAM. Now Z in Linux and in Unix stands for compression, so it's compressed RAM. So what's the idea? Instead of actually writing out that page that it's found in memory that's not being used to storage, it writes it out to another area of memory that's been reserved beforehand, but that area of memory is compressed. So that means if you had, let's just start with 1 megabyte of RAM that you wanted to swap out, and then you write it to this special area of memory, if you write it only 500k, then you've freed up 500k. So it sounds a bit counterintuitive that you're going to copy memory from one place to another place so that you can free up memory, when that in itself is consuming memory. But the point is it's consuming less memory, and the difference is the free memory that you can then have. Now you can get ZRAM swapping available for the Raspberry Pi, and it's really easy to install and actually can do quite a lot to boost the performance and the feel and the speed of a Raspberry Pi, particularly at the low end, half a gigabyte, 1 gigabyte, and so on. So now we're going to go over to the Raspberry Pi and actually look at how we can do this. Okay, so here we are on the desktop of a Raspberry Pi Zero 2. So that's a quad-core 64-bit ARM processor, but it has only 512 megabytes of RAM, and we're running the desktop, which is a pretty ambitious thing to do, I admit that, on a device with such a low amount of RAM. However, it does help demonstrate this problem of swapping and activating the ZRAM. So here we are. What we can see is that we're using about 200 megabytes of RAM right now, of an available 427 megabytes. Some of it also is given over to the GPU, and about 31 megabytes of the swap file on the SD card has already been used. And we can see that quite quickly this kind of number can go up if we go here into accessories and maybe start text editor. it's going to go and start that, and we start to see a bit of pressure. Look, that's gone up there a little bit on there. We can open up the file manager. That's going to make things go up a bit even more. Where are we now? So 42 megabytes of the swap file being used. We're slowly creeping up here in the amount of main RAM being used. What else can we start? Let's start a calculator. Okay, these are just little programs, really little programs. If it actually starts like a web browser, this will go even, you know, right through the roof, really. Let's see if there's anything a bit bigger here that can push it a bit harder without me having to start the web browser, because that is the one that really does kill it. So, all right then, so there we are at 216 megabytes of memory used, 42 megabytes of the swap file used. Run another terminal here, see if how that does. Okay, so it's slowly creeping up. Let's start Thonny. That's the IDE for Python. Very good IDE for Python, highly recommended. Let's see how that gets us along here. Okay, right, this has gone up now to 60 megabytes used, 231 megabytes of RAM. So you can see as you start more programs, the pressure increases, and particularly the pressure here on the amount of swap space you've got. Okay, so we're going to shut all that down again now, and then I'm going to show you how to install ZRAM. So the first thing you should really do is make sure that your list of the repositories is up to date, that the system has got all the latest patches installed, and you do that using the very standard sudo apt update and sudo apt upgrade. Once that's complete, I've done that previously, we can then move on to installing the ZRAM. Of course, I'm saying ZRAM, all the Americans are going to say, no, Gary, you should be saying ZRAM. Anyway, the way you install it is you install ZRAM hyphen tools. And then we just go ahead and install that onto this system. Now, once that's completed, that's it. You've actually got the ZRAM actually up and running and configured on your system. If we go back into HTOP now, we can see a different situation. Now we're at 356 megabytes of swap space available. So, that's very close to the amount of RAM that there is. So that's a combination of the ZRAM, and the SD card RAM. Okay, and we can look at it in a few other ways. There are a few tools that help us. One is ZRAM CTL, and that will list us here. There is now a swap device called ZRAM 0. It's using the compression algorithm LZ4. It's 256 megabytes in size, and so far 23 megabytes of main memory has been swapped into it, and doing that, it's only occupying 14.5 megabytes. So that's really interesting. We can see it's not quite 2 times half, here, the compression, but there we go, it's actually up and running. And another good file to look at is you can do a cat of /proc/swaps, and that will list out, and here we can see that it's got the var/swap, which is the swap file on the SD card, and it's also got the ZRAM file there that we've created. So there we go, it's actually up and running. So let's give it a test and see what it does. So we're going to start those same programs we started before. Start the calculator, start the file manager here. We can start the text editor. Okay, and what we're seeing is as we're doing this, okay, the pressure on here is going up, but this is actually going into the ZRAM now. Going into the ZRAM and not writing to the SD card, which actually means that the system is actually a bit more responsive. I don't know if you've saw it there as I was doing things, but things are certainly coming up a bit quicker because it doesn't have to write to the SD card to do all that stuff that it was doing before. It can just go ahead and it swaps into the ZRAM, which is much quicker than physically writing out to what can often potentially be a slow SD card. So there we go, things are working there, and it's actually a lot snappier. And in fact, if we now go and run that ZRAM control thing, we can see now that 32 megabytes are in the swap, and only 20 megabytes of RAM are actually being used to do that. So we're gaining every time we do this. Although we're swapping to compressed RAM, we're actually gaining RAM. And that's the whole idea, because now what would have taken 32 megabytes only taking 20 megabytes, and so this free RAM has been freed up for other programs to start. And let's actually do the killer test here. Let's try and start the Chromium web browser and see what happens here. So there we go. Let's go ahead and just click that there. Okay, so I've gone ahead and opened up the raspberrypi.com website. It's telling us about the Raspberry Pi 5. I hope you've had a chance to watch my video about the Raspberry Pi 5. But look over here at the RAM usage. This is the point now. See, 250 megabytes of swap is being used. At this point, if we had only that 100 megabytes, things would have been very different. It would have used up all that 100 megabytes. And maybe even I've had the system freeze. If you just try too much, it just can't get out of memory, basically, and it can't cope. And we've got 250 megabytes of main memory being used. Now, if we now run the ZRAM control program again, we can see here that 175 megabytes has been swapped out of main memory into ZRAM, which of course is in memory, but it's only occupying 77 megabytes. So we freed up 100 megabytes in doing that. So this is what the advantage of ZRAM is. So there we go. Now this is running on a Raspberry Pi Zero. In a minute I'm going to show you how you can actually do this on a Raspberry Pi 4. Even when you've got 4 gigabytes or 8 gigabytes of RAM, it can still have an important role to play. However, before we do that, there is some tweaking you can do to make this even more responsive on a low-end memory system. Okay, so there are 2 files that we can play around with. So let's look at the first one, and this is /etc/default/ZRAM swap. And here is a file that lists some of the things that you can change. So for example, here you can pick the compression algorithm. So in terms of speed, LZ4 is better than Z standard, which is better than LZO. Okay, and so we're using LZ4. However, in terms of compression, Z standard is better than LZO, which is better than LZ4. So you can see here we're actually using the lower one. So maybe, as an experiment, we can actually go ahead, let's edit this file. So we can actually go ahead and change this so that we're going to use a different algorithm. Let us use Z standard. That maybe give us more compression. And another thing you can do is actually set the size. So we saw it was 256. Okay, so it kind of defaults to a certain amount of the main memory. You can override that here. I think for a Raspberry Pi Zero, we'll make sure it's as it is. And it's also interesting, you can actually just make sure you change that priority there to make sure that it always swaps out to the ZRAM before it swaps out to the SD card. So that's really important to do that. And once you've got that file saved, you can then restart the ZRAM service. So you do that using syscontrol. So just restart ZRAM swap, which will go ahead and do that. And of course, to do that, at some point, it actually has to, all the main memory has to go somewhere else. So you wouldn't want to do this while the system was heavily being used, because suddenly that ZRAM will disappear while it recreates it under the new parameters and brings it up again. So you don't want to do this when the system is heavily being used, because all that stuff that's swapped out to the zero has to be somewhere, has to go somewhere else. So let's go back into HTOP here and see how we're doing. So we can see basically we're in the same situation. It will be interesting to see now if we did start to run these different programs like we did before, whether we can see a noticeable difference in terms of the compression that happens inside of that ZRAM partition there. What was the other thing that I ran? Oh yes, Thonny. Let's run here like that. Okay, now let's run ZRAM control, and there you go. Look at this now. So 23.8 megabytes being used, only using 9 megabytes of memory. So that's doing a better job at compressing it, which means in itself it compresses, it frees up more memory, but to get that it's slower. So while the swapping process itself will then become marginally slower. Okay, there are some other parameters you can change. These are not actual parameters for the ZRAM system. So for example, the algorithm and so on, as we've just done. These are for the Linux kernel itself, which tells the Linux kernel how it should do swapping in general. So it will also apply to the file-based ones on the SD card, but it will also apply to ZRAM. So what you do is edit this file /etc/syscontrol. We need to put an editor in there. Okay, now you can edit this file, and here is a file of the parameters that you want to pass to the kernel and tells the kernel how to behave. And so what we're going to do is we're going to add some lines in here at the bottom that are useful for getting different kind of a performance out of the kernel. I'm not going to go through all of them here. Let me just give you an example. Swappiness, for example, tells the kernel how aggressive it should swap. Should it swap early? and do it, preempt it, do it when things are just a bit of pressure starting to build up. Yep, swap now. Or should it be really lazy right until the last moment when things are just about to collapse, unless it does some swapping, and then it'll go ahead and do some swapping. And these other different things here, they've kind of been tested on the internet. Different users, different groups, different distros have kind of come up with some of these numbers. And if you use these, you may get a bit better performance out of your ZRAM swapping. I do have some documentation that goes with this tutorial, and I do explain all of those individual parameters there in that documentation if they actually interest you. So what you need to do now is save this file, and then we need to actually get the Linux kernel to absorb those new to read those new parameters. And the way you do that is with syscontrol -- system. It will go ahead and it will apply all these new different things, and we can see here swappiness at 100 and so on. So we can see they've all been applied, and those are now what are being used. And if we go now into HTOP again, we can see whether we're going to get any kind of different numbers here. Let's try and start up a few of these programs. Okay, we've got some programs running there, and you can experiment to see what you think of all this. Let's just run that ZRAM control program. That's showing us now that we've got 34 megabytes swapped out, 12 megabytes in compression. So again, a good compression ratio going on here, almost getting to 3 times compression ratio. And you have to see whether this actually helps in terms of your overall performance. So there you go. There are some things that you can do to get ZRAM. We're going to show you now on the Raspberry Pi 4, just to show that it does help there as well, and can increase the speed of your system overall. Okay, so now here we are on a Raspberry Pi 4, also a quad-core processor, but now of course we can see we've got 3.7 gigs of main RAM, and look at this, 2 gigs of ZRAM. That 0.1 there, that's actually the 100 megabytes that you get on the default installation because of on the SD card. The rest is all just ZRAM. So again, we can run the ZRAM control program, and there you can see it's 2 gig. But now that's 2 gigabytes. To notice here, that 2 gigabytes is uncompressed. So the swap file, the ZRAM, will keep working to say how much of uncompressed data it can take, and then it's actually compressed, as we've seen in the previous video, and that's the actual RAM that it's using. Now, obviously, if we start up some of these small programs like we were doing earlier on, they're really not going to make much difference at all to a 4 gigabyte version. I mean, here we go. Look, a few more megabytes being used here. Nothing's happening on the swap space at all. Even if we start up something like Thonny, that's not going to do anything. Now, what we can do, of course, though, is start up a few other programs to see if we can get some pressure applied on this. First, we can run Visual Studio Code. That does put a bit of pressure on the RAM there. Let's see what happens. Okay, so there's Visual Studio Code up and running. Let's see now. No, nothing's happening in the swap space. Obviously, the RAM usage is going up there quite significantly. Okay, so, well, of course, the next thing to try really is the browser. So we'll open up the browser here and see how that does. Okay, so the browser is up and running. I've got various tabs open, including the Android Authority website here, and in fact, a PDF file, which is an ebook that I bought. It's nothing illegal here, and it's about Blender, and it's a 250 something megabyte file. And even with all of that lot open, we can still see we've got plenty of RAM going on here. Nothing's happening in the swap file yet. So I suppose we need to open up a few more web pages. Okay, I've opened up a few more web pages, including the Gary Explains YouTube page, and now we're starting to see some pressure. And you can see that 261 megabytes has gone out to the swap. Now, here's the important thing. Because this is swapping aggressively, this 260 megabytes here, obviously we've still got about a gigabyte of main memory here. This is stuff that it's better to get rid of so that memory can be used for caching, can be used for quickly launching of other apps. When you open up a new web page, you can get hold of the memory quickly. And so having that stuff moved out to the swap is actually really good because it gives you main memory available. And now, rather than having to write it to the SD card, which could be quite slow, it's actually now using the ZRAM. So that actually does improve system performance. And obviously, if you had an 8 gig version of the Pi, then it's going to be very different. Again, as you can see, 218 megabytes being used, but only 60 megabytes is actually of real RAM is being used because of the compression that's going on. Now this will be really interesting to see what an 8GB Raspberry Pi 5 will do. And don't forget, I do have a video about the Raspberry Pi 5, as I mentioned earlier, and when my board comes I'll be giving it a complete full review, including testing various things to do with the memory and the performance and all that kind of stuff. Okay, so there you go, swapping using SRAM. I really hope you enjoyed this video. If you did, please do give it a thumbs up. If you like these kind of videos, then why not stick around by subscribing to the channel. Okay, that's it. I'll see you in the next one.